Let's look at the last of the AP Live worksheet problems here. This is number 19. Let the function defined by f of x, which is the definite integral from 0 to x, 2t cubed minus 15t squared plus 36t, on which of the following interval is the graph concave down. So we have to recognize that this function that we see in front of us is sitting one level above this expression that we see here. It's the integral of this expression. That's what that function is defining. So if I want to work my way down to the second derivative, first up, we know that this expression we see inside the parentheses is really sitting at the derivative level of f of x. It's really sitting at the f prime level, because the integral of this, if the integral of this function will take us up to f of x level, that means this must be sitting at one level below f of x, which is f prime. So we can also use second theorem to indicate that if I want to find the derivative of a function that has the definite integral, we know those two operations kind of undo each other. We're left with just what's inside the parentheses. So what you see inside the parentheses is really the f prime graph. So now, once we identify that f prime function, we're going to find the derivative again to go from f prime to f double prime. So power rule, 2x cubed becomes 6x squared, 15x squared becomes 30x, 36x becomes 36. We set f double prime equal to 0, factor the 6 out, continue factoring, we get 2 and 3. We place 2 and 3 onto our concavity sign line. We test values in each of the intervals into the second derivative. So we get positive, which is concave up. Plug 2.5 in, we get negative, concave down. Plug 4 in, we get positive again, so concave up. Our function is concave down, therefore, from 2 to 3, since f double prime is less than 0. Right, number 20. We have a graph of piecewise linear function that is shown here. The graph in front of us is the f of x graph. We want to find the value of the definite integral of f of x from -4 to 8. So that means we're going to total the region between the graph and the x-axis. So I shaded those regions in. So from -4 to 8, these are all triangles. We can just use 1/2 base times height to find each of the areas. And I just have to make the adjustment that above the x-axis is going to result in the positive value. Below the x-axis results in the negative value. Accumulation of negative y values there. So 1/2 base times height for each of these. And then if we total these up, we get -1 plus 5 minus 3 plus 2, which is positive 3. Part B, again, f of x is shown. What is the value of the integral of f prime of x? The integral of f prime. So we don't have f prime in front of us, but we can use the fact that first theorem tells us the integral of f prime brings us up to the f of x level, right? So I can use this to help me with this form. The integral of f prime is therefore f of 8, upper bound, minus f of -4, lower bound. So now we have something that we can use. F of 8 minus f of -4, these are just ordered pairs off of my f of x graph. So order pair at 8 is 2. Order pair at -4 is -1. So we just do 2 minus -1, which is positive 3. Okay? Coincidence with part A, but completely different way of finding. Part C, the graph of the piecewise linear function is also shown here, same graph. What is the integral of f double prime? So just like with first theorem, we can apply that. If we take the antiderivative of f double prime, this is going to bring us up to the f prime level. So we can say f prime of b minus f prime of a, in this case f prime of 7 minus f prime of -3. So f prime of 7 is just the slope of the f graph at 7, which is going to be a positive 1. And then f prime of -3, the slope of the f graph at -3, that's just a positive slope, right? Up 1 over 2, so slope of 1/2 there. So we have 1 minus 1/2, which is 1/2. All right, 21. f and g are continuous functions. We have the definite integral from 0 to 8 given to us. We have the definite integral from 0 to 8 of 2g of x equal to 4. And we're trying to figure out what is the definite integral from 0 to 5 of f of x minus g of x. And we do have this integral from 5 to 8 being 3. So let's establish something that we can start off with. We know that the full region from 0 to 8 of f of x minus g of x is equal to the sum of the integral from 0 to 5 plus 5 to 8. And the reason why we split it up from 0 to 5 and 5 to 8 is because we want to take advantage of this special property here. Okay, if we can replace this 5 to 8 with a number, then we can solve for 0 to 5 because that's what we're looking for. So if we can figure out these two pieces, then whatever the resulting value of these two added together, combined together, is going to be our integral from 0 to 5 of f of x minus g of x. Okay, so the integral from 0 to 8 of f of x we know is 12. The integral from 0 to 8 of g of x, we have to kind of clean this up a little bit in order to get to where we want to be. So if I want to find the integral of g of x, I have to find a way to get rid of that 2. So if I divide 2 from both sides, I get integral of g of x from 0 to 8 is 2. So we know that 0 to 8 is 12, 0 to 8 for g of x is 2, so we subtract those two, we get 12 minus 2 is 10. So therefore we know that this portion is 10. And if I want to figure out this portion, I can just subtract the 3 over, 10 minus 3 is 7. Therefore the definite integral of f of x minus g of x from 0 to 5 is equal to 7. All right, 22. We have a function that's continuous. The integral from 0 to 8 of f of u du equals 6. What is the value of definite integral of x times f of x squared minus 1 from 1 to 3? So we see that hopefully this is a way for us to kind of see that, okay, we have something that we can use. If this should connect to this, but the reason why it looks different is because it's before u substitution. So if we can start with u substitution, we can hopefully convert this to be in terms of u, and then we can see what proper substitutions we can make. So we'll let the u value be what's inside the parentheses. U is x squared minus 1. We find the derivative, we get 2x. Solve for dx, we get du over 2x. We make our substitutions. Parentheses gets replaced with u. Dx gets replaced with du over 2x. X is canceled out. We can push that 2 out in front as 1/2. And now we have the integral from 1/2 of f of u. But let's convert these also to be in terms of u, so we can make sure that we're adjusting for each of the parts that need to be adjusted. So if I want to convert the bounds, this is my x value. I'm going to push it into this formula that connects u and x together, which is u equals x squared minus 1. So we plug 1 in for x, we get 1 squared minus 1, which is 0, so my new upper bound is 0. Plug 3 into the x value, we get 3 squared minus 1, 9 minus 1 is 8. My new upper bound is 8. So now the integral from 0 to 8 of f of u du is going to be 6 with the 1/2 in front, so 1/2 times 6 equals 3. All right, 23. We have a definite integral, but this is not something that we can plug in the calculator, right? We're going to have to work this out by hand. So b is just the numeric value, just the coefficient. Let's go through power rule here. Power rule, upper bound first. Well, first off, power rule, x becomes x squared over 2, x squared becomes x cubed over 3, with the coefficients out in front. Let's plug in our upper bound followed by lower bound. Upper bound gets plugged in for x. We get 4b cubed over 2 minus 2b cubed over 3. And then the lower bound, in this case, a 0 is going to wipe everything out. I'll clean up our equations here. We get 4b cubed over 3 is equal to 36. Cross multiply. 4b cubed equals 108. Divide both sides by 4. Take the cube root. We get b equals 3. Right, 24, same idea. We're going to go through power rule. X to the 7th becomes x to the 8th over 8. K becomes kx. Plug in upper and lower bound here. Upper bound gets plugged in. Minus, then followed by lower bound. We set all this equal to 16. And now we should be able to work our way down to solve for k. 2k plus 2k equals 4k. Divide both sides by 4k, we get k equals 4. Hey, last one here, 25. Consider the differential equation. We have f of x be the particular solution with the initial condition of order pair 2, -1. So first up, I'm going to cross multiply. I'm going to let this whole expression, as messy as it is, to be in the numerator. Cross multiply, get dy is equal to 1 minus 4 over x cubed times y minus 1 squared dx. There's still something out of place here, and that's the fact that this y minus 1 squared needs to be with this dy. So I'll divide that over. And once that's divided over, now I have a clean separation. Now I can decide which integral rule is most appropriate for both sides. The left side here, it's going to have to be u substitution. But I'm going to bring that y minus 1 squared up to the top to get it ready for power rule afterwards. And this, second, on the other side, I can split up into two separate problems and do power rule for each. Okay, left side, u equals y minus 1. We're going to replace these two pieces here. Let the u value be y minus 1. Du equals over dy equals 1. dy equals du. We get it in terms of u. We do power rule, u to -1 over -1. And replace the u back in terms of the original variable y. The right side, we do power rule. 1 becomes x. 4x to -3 becomes 4x to -2 over -2. Don't forget plus c. Clean up the right side. Once everything's in terms of x and y, I'm going to plug in my order pair 2, -1, which is the initial order pair given to us. 2 plugs in for x, -1 plugs in for y. We clean this up, and we get positive 1/2 is equal to 2 plus 1/2 plus c. We get c equals -2. Now we replace our c value with -2, and let's see what we can do to clean this up. Multiply everything through by -1, or actually cross multiply here. I can divide the x over. I can take the square root of both sides. And finally move that plus 1 over to the right. So now I want to figure out what is the order pair, what is f of 1 equal to. So we'll plug 1 in for x, but here we run into an issue here. We get 3 minus 2, which is 1. -1 over 1 is negative. Now we can't have a negative inside the radical, so this is going to be undefined. Order is not going to exist inside our real number system, so therefore y of 1 or f of 1 is undefined.